All right, so let's talk a bit about Rust programming. This is going to be a very small project. We're going to write a small command line application, learn along the way about how to start a new Rust project, the Rust analyzer, finding using packages. Well, I recently learned about the shuf GNU program in the core utils. And what it does is it shuffles input text by outputting a random permutation of its input lines. Okay, so let me start again, remove the folder. Okay, actually, here's our example input, a bit of Shakespeare. So let's get started. Cargo, new. Cargo is the Rust package manager and does the building and everything for us. So we're going to use it a lot. How to install Rust? Well, you go to rustup.rs. That installs Rust and Cargo. Very much recommended. Cargo new minus help. It takes some options and a path. Well, I'm going to call the path shuf, and if we use it that way, the program name is also going to be called shuf, but we could change it if we wanted to. So we have a new directory shuf, and then we can just do cargo run, and it will print a hello world. Let's open let's close this. Let's open the directory like so. And I need some extensions. So the most important one is the Rust Analyzer extensions, and it will be extremely helpful for us. And the less important is the crates extension, which is just used for this cargo.toml file. For everything else, we can ignore it. So how does our project look? Well, we have a target directory that we can ignore. That's where the build is. We have the source. Okay, give that a second. We have the cargo.toml file, which is some metadata, a useless comment we can ignore, and dependencies, of which we have none. And let me just enable the screencast mode so you can see how I opened the terminal. Okay, back to this. We can close this. Again, cargo run. Builds in it. Everything is in debug mode. We don't have to build in debug mode, and maybe at the end we won't. Okay, so the program that we are gonna re-implement is GNU shuf. Random shuffles lines of a text file, and we're only gonna open a file and have this mode version. It has some other options that we ignore for now, but they're not hard to implement in Rust. So we need to open a file. We need to read all the lines, shuffle the lines randomly, and then print them. Let's do this. Well, how do you open a file in Rust? Well, it's pretty simple. You Google it, and that leads you to this page. I'll Google it for you. So Rust open file leads you to this page that I just had here. We want to create a new file. No, we want to read the content into a string. You can also use read. Sure, let's do this. If can be more efficient to read the content with the buffered reader, this can be accomplished with buff reader. All right, so let's just copy all of this. We have some includes here. We have a buff reader. We print the contents. Okay, it expects hello world. So what is it's called /example.txt. The contents into a string, read to string, buff reader. Okay, we don't want to assert anything. We just want to print contents. Let's use print line For whole file, it doesn't make a difference, but let's do this. Let's see. There we go. It's our prints our text. Obviously, a lot of things aren't great with it. So what do you need to know? The OK at the end is really a less verbose way of saying return OK of something, and the something is this. This is the unit type, or also known as void if you know C and C++. And then the return can be elided if you leave the semicolon away at the very end. Gives you this. You already see, I copied this from here. Right, let this line here, let file equals file : open. There's nothing behind it, but you can actually see that the Rust analyzer put the :file there to tell me that file is of type file. Same for buff reader, same for contents, it's of type string. Not super useful now, but as you add more and more variables to your code, and if you maybe get this from another method, you might not know what the type is. And so this annotation is useful. It's not, you could always manually add this, but for flexibility, it's normally not added. Okay, so we want to read this as lines. We want to read all the lines, so not everything at once, just all the lines. Let's remove this here. And buff reader has a method called lines. For line in lines, and you can see already the type line is now a result of string or an error. Right? So it can contain either a string or it can contain an error, and then in Rust, let string line equals line question mark takes the result string or error and just gets us the string. What happens if there's an error inside this line variable? Well, it jumps out of the function. This is the question mark operator. It's extremely useful in Rust. So, and then we can do print line. Sorry, here we go. Okay, it says the buff reader doesn't need to be mutable. So command period gives us options here. And done. The warning is gone. It complains about core string not being needed. Okay, we'll remove that too. And we print out the text successfully, line by line. Before we continue, we obviously don't want to hard code the path in here. For that, there's a crate called structopt, which I'll show you briefly. So I'll have the documentation here. This crate defines the structopt trait and its custom derive. Well, that's a lot of words that don't mean anything. But what it does is, if you want to write a command line application for really the basics, and you can customize everything, but for the basics, you can just create a struct of your options, and then, so this struct here, in your main function, you fill it from the arguments. So let's do it. Copy these two lines. First, we need to do cargo add structopt, and you'll see that the file here now has this line that got added with cargo add. Okay. So first things first, we want to let opt from args and print it. But we need the struct here. That's great. So let's have a struct. That's a pretty boring struct. And we need to import this. Oops. We don't need all of this. And then this is going to be called re-implementation of GNU shuf. shuffles lines of input randomly. Cannot find this macro. Yes, we need to do this. We need to use it. Use structopt. Okay, let's run it. And this is the opt line. Okay, options. And then if we run it with -- help, we get shuf, a reimplementation of GNU shuf. Well, that's the text I wrote up there. The version, which comes from this line here in the toml file. The usage, okay, just there's no options at all at the moment. It has a version and a help flag that come by default. So let's give it an option. Well, we want to have the struct needs to have a file as the input, which is of type string. All right. Now let's run it again. Look at this. Now we have an argument called file. But we need to do a little bit better. We want to use this part here, right? We have a path buffer. So it's not just a file, it's actually representing a path. So let's have that. So this is path buff. Like this, input file, and we keep the rest. It doesn't know about path buff, so imports the path buff. All right, input file. And now we can provide example.txt. And it says here, options, opt is a struct opt, where file is .. example.txt. Well, that's pretty good. Well, let's replace it here and use it. Opt dot. All right, now we actually are opening that file. That was pretty simple, I think. Good. Now we want to randomly shuffle the data, and there's a crate for that. There's always a crate for it. If you search for random shuffle a vector, this is what you find. The rand trait has a slice random. So let's add this. Cargo add rand. We need a random number generator. Okay. And then we just call .shuffle on it. Random number generator. Now we need our vector, so let's have a vector called lines. Okay, so you see this line buff. This is of type lines on a buff reader, implemented on a buff reader of file. So you think we could do lines.shuffle? We cannot. What we actually want is we want this to be a vector of some sort. So the underscore here means some sort. Vector obviously means what it does, and then we collect it. So lines is implementing the iterable type, the iterable trait, and the collect method collects it into a container. You can have the documentation here. Let me find it for you if I don't have it open yet. Rust iterable. Here we go, std iterator. All right, an interface for dealing with iterators. This is the main iterator trait. Please see module level documentation. Yes, you should really read it at some point, but here we have the collect method. To transform an iterator into a collection. Can take any iterable and turn it into a relevant collection. Well, what is a relevant collection? Is to turn one collection into another. You take collection, call iter on it, do a bunch of transformations, and then collect at the end. Right? Iterators are inherently lazy, and the collections is this. So here we have an array of, I guess, ints, 1, 2, 3, and then it's iterated over with a map. It's very functional programming like, returning twice the value, and then collected. Well, collected into, and here we need a type annotation vector. But you can collect it into something else. You could collect it into vec of deck, and so on. Let's see. So we want to collect this. This should compile. Let's run it again. We'll get a warning because we're not using RNG. And we're not mutating it yet. But now we can call lines.shuffle. Actually, we should make it mutable now. So we need to get the, so we need to have a mutable reference, right? A reference which needs to be mutable to RNG in here. This won't compile. This will compile. And whether it is noble in the mind to suffer. Well, it's all wrong now. The order is all wrong. It's good, right? All right, so how can the Rust analyzer help us? Well, let's just imagine I didn't know that lines had to be mutable, right? Everything is by default immutable in Rust. Well, now I get this little line here that says, consider changing this to be mutable, okay? And I can do it. I can hit enter now, it would be mutable. There we go. Let's say I don't know that RNG needs to be a reference, and it says, consider mutually borrowing here, okay? Well, that's, there we go, problem solved. Just one click away. It's Rust Analyzer is really for the lazy. It's almost always right. And you can also rely on the compiler, but will also give extremely useful error messages. So let's just run the compiler. Cargo checkers if built, but faster. This cannot borrow lines is mutable as it's not declared as mutable. Well, makes sense. Here lines that shuffle cannot borrow as mutable, right? This line needs to be mutable, and consider changing this to be mutable lines. So let's just do that. That's it. Is it? It's not. What happens? How can we break this? Well, we can break it with an input that doesn't exist. Does not exist. All right. Now we get this error OS codes to kind not found message, no such file or directory. This is ugly. We need to fix this. So we're going to use some favorite crates of mine called eyre and color-eyre. So color-eyre. And let's open the documentation real quick for that. So we want to use, we want to change the result. Right. See how we're returning is the IO result? We don't want to do that. I want to return a color-eyre result, actually. This already looks better. It could look nicer. We want to install an error handler. So not always appropriate, especially if this is not for a command line application. You might have something else. You might want to get the errors into the log files, for example. But in this case, we're going to make it all pretty. Okay, a bit of formatting, a bit of color added. It says backtrace omitted, but if you want to backtrace, you can say backtrace equals 1. In this case, we don't. We want something else. We want, this is a useless error, right? No such file or directory. Well, what was the file that we gave it? Is the obvious question. So let's add a little bit of context to this line that failed. Which line failed? Well, the open file here, right? So let's do context. Format file, so does not exist. Actually, no, we should say could not be opened. Right? We don't know why it couldn't be opened at this point, and we want opt.file. And then we get an error here. What's the error? The method add a use for it. Okay. Let's see. Just doing this here. Help, the following trait is implemented but not in scope. Perhaps add a use for it. Well, use IR wrap error. Okay, let's just do this. All right, so this takes this trait, which extends our error type to have this context method. Now we'll get a different error, which is about ownership. Rust has this concept of the so-called borrow checker, and people complain about it or have complained. It can be a bit annoying. What it means is that a variable can only be used ever once at any time. That's not technically correct. You can have multiple things read it, but you can't have something read it, use it, and potentially modify it. This is to avoid copies. So we don't have, there shouldn't be any copies most of the time, right? So what happens here, we have the file open, takes the opt.file, the path, right, and consumes it, moves it. And then here we have the context to print it, but this is called a borrow, right? It just needs it to read, just borrowing it, it'll return it. But since the borrow happens after the move, it's not valid anymore. There's a bunch of solutions. We could format the string first, right, and use it in case. We can also do the wasteful thing, which is what I'm going to do, which is I'm going to clone, so copy this, explicitly copy the file with the path at this location. So we have two versions of it. That's not optimal, right? That's performance-wise not smart, but performance-wise we also have other problems here. I'm not trying to do it. This is just a simple solution. I think it's appropriate to use this simple solution here. Again, keep in mind we are opening the file into memory. If the file is big, it's going to be slow anyway. Now let's run it. Cargo check should go through. And look at this. Error 0. Line file does not exist, could not be opened. No such file or directory. That's the error message. Right now we have our context. Really, that's all we wanted. Let's just go back here real quick. We open the file, we read all the lines, random shuffle lines, print a shuffle lines 5, handle errors appropriately. Right. In this case, appropriately means telling the user why it didn't work. We use the structopt crate to take a struct and generate arguments from it. We use the eyre and the color-eyre crates. Eyre is an extension of anyhow, so you might come across anyhow error handling in Rust. I prefer eyre these days. Then we use the random shuffling using the rand thing. You saw the Rust analyzer, which saw a little bit the crates extension, not as useful. Rustup.rs is where you want to start. I'll put the links that I opened in the description of the video. Well, what else could we do? We could do a lot of things, but I'll leave it at this. Do we have anything? Did I miss anything? I don't think I did. I hoped you liked this walk through Rust. Again, we have some imports at the beginning. Our structopt here with a path buffer. We use the color-eyre to get beautiful output in case of an error. We use argument parsing from the structopt crate. We have our random number generator that we will use later in the program. We open the file, we open the buff reader, we read all the lines here, collect them into a vector. So this is the point where everything gets read into memory. We have our vector of things. What are these things? Well, there are results of strings or error. Right. We shuffle them and then we print them here. Right. This question mark extracts the string from the result, and then we print them. Oh yeah, I could of course write this like so. And save a line. We could not read everything into memory, but maybe read the length of the length of the file. If it's very long, bunch of solutions. We can add more options that are in the GNU Shuffle program. Yeah, so we can publish this if we wanted to crates.io. It's very simple to do. One more thing we can do, also do cargo install the current package like this. Then it'll get built for debug mode. Sorry, it will get built in release mode and installed in the cargo directory. So I did install it before, so we get a replace, right? But if I run shuf -help, I get this. That's the one I just installed. Here we go. I can also cargo build --release. And the target directory, that's not helpful. Target directory looks then like this. So there's a release folder now with the shuf command. Yeah, I hope you enjoyed this little introduction to Rust. Obviously much more to learn. But I hope useful as a start nonetheless.